Welcome back, Badi. Welcome back, my dear support. In the interest, compound interest. We'll talk about some points today regarding the compound interest. Here we have an example to compare between simple and compound interest. How to compare comparison between a simple and compound interest. So once we started here, let's say that the principles for 10,000 for terms of 5%, and of course, the rate of interest is 6%. So let's say like this, you slide the interest rate equal 6%. And the time, let's take the time, the principal is 10,000. Principal is 10,000. P is 10,000. So the R is like this, and the P or the present is 10,000. And we have also for 5 years, terms of 5 years. So terms of 5 years. Terms of years for the time will equal 5. I think it's very simple that we will get the future value now because we know this before. Future value will equals the P principals multiplied by 1 plus the R times the N, R times the T. T is the duration, R is the interest rate. So when we apply this right now, when we apply this, it will be the 10,000. This 10,000, let me enlarge so everything, if the fonts, you guys can see it properly. The 10,000, then I will open a bracket, 1 plus the R. The R is 6%, like we said, so interest rate, 6%, 0.6 multiplied by time times 5 years. So this will equal 1.3, 10,000 times 1.3, 10,000 multiplied by 1.3. After I finish this first, I will go to finish this amount, then add it to 1. It will be 1.3, like what you see here. Then that will equal 10,300. Let's go back and see, check here. Yes, it's 10,000. Here it will be, sorry, it will be 1,000. Sorry about that. It will be 13,000. Yeah, because this 10,000 times 1.3 will give me 13,000. Okay, this is the sum if it is simple interest. Simple interest. Simple interest. Oh. How about if I want to do it compound interest? The second part is the same ideas here. I will take those three are the same, but now let me insert a new slide. And I will do it right now, compound interest. The same data, compound interest. Compound interest. How it will work here now? Now we say in the compound interest that the future value will equals P as there as well, multiply by 1 plus R. The R is the rate of interest. The power is N, whereas N is the time, or the T, whereas N or T are the time. Whatever you want to choose for samples, you can use T or N. It gives the same meaning or same understanding. When we substitute here right now, so we'll say the future variable equals the 10,000. Here it is, Control and C, the 10,000. Here we go. Then multiply by 1 plus the R. The R is 6%, 0.6. But now take, wait. We have this now time. It will be power. The power of 5 years. So it will be 106 power 5. So how I will do it? I will do it like this. 10,000 multiply by, I will actually go to 106. This is will equals like this way. I will show it to you. 1.06, and that will be power. Here is the power 5. So I'll go and see 1.06 power 5 and check out how much it will be. Here, let's go for C. From the start itself, let's go for C. Then I will say now 1.06 xy power 5. That will equal this amount. Control and C, and I will go and put it there. That will equal 10,000 multiplied by the amount which I took from the calculations here. So it will equals 13,000. The same number, but I will move it 13,000. Control and C here. I'll put it here right now. Control and V. But it will be 13,382. And without the decimal point here, 13,382. And here it is, point, blah, blah, blah. Let's make this this way. Here it is. I will enlarge it. Here, the final result, and we can get it here as well. Here it is, 13,382.26. The same results which we get. 13,382 point, because here, and here it is. So what is different between the compound interest? You see the number here. Forget about the integer. Just take the number here, 13,382, and compare it with the other number here, with the simple interest. Here it is, 13,000. So that means that means that the compound interest is greater than simple interest. Compound interest is greater always than simple interest. Consequently, because we said we count the interest based on the principals plus the interest as well. Every time we calculated based on this. So in this example, we saw that compound interest is greater always than the simple interest. That is why is this idea. So even for the same period of time, we find that the compound interest is greater than simple interest. Okay, what about if we have fractions? As example, if I give you semi-quarterly. Semi-quarterly means every half year. Okay, and quarterly means every 3 months. So semi-quarterly, let's say now, right now here, just write it like this, new slide. When I say quarterly, Q-U-A-R-T-E-R, quarterly means because the years are 4 quarters, every 3 months. This is the quarter. Semi annually means every 6 months. Annually means every 1 year. So this is also things which I want you to know, and it's very important for you to know it while working in this. Why we say like this, I will tell you. Let's go now for an example like this example here. And let us see here in this example, we have the interest rate 4% quarterly. Quarterly means every 3 months. Means that 4% in the year, 4% for the whole year. Compounded quarterly means 1% every quarter. 1% every quarter. So as example, 4% divided by 4, that will give me 1%. So to solve it, the first thing is to say 4% will divided by slash 4, then it will give me 1%. So if it is 4% for the whole year, then it's 1% for a quarter of a year. That's the meaning of it. If it is 4% for the whole year, then it's 1% for the 1 quarter. Okay. And also one thing more. Now, how many quarters? Okay, let's go now. It's for how many years? Let us see for how many years the future value accumulated for the maturity of saving certificate with a principal of 5,000, earning interest at 4% compound for 5 years. So 5 years have many quarters. This is the second point. How many quarters in the 5 years? So 5 years. So the quarters, number of quarters will equal the 5 years, and each year has 4 quarters. So that will have 20 quarters for the 5 years. 24. So what we do always, we usually divide the rate multiply the time. And that's how it works. We divided the rate here. The rate of 4%, that means in the whole year, 4% annually, but we have to do it for 1 quarter, for the quarters, for each quarter, because the year is having 4 quarters, so 4% divided by 4 will give me 1%. And for the quarters, for the time, this is for the rate. This is for the rate. But for the time, how many quarters we have? We have 4 quarters in the year, but they are 5 years. So here, time, we multiply. So we have, it's 5 years, and every 1 year is including 4 quarters. So 5 times 4 will give me 20 quarters. Now I change it for that reason I told you here. Divide the rate, multiply the time. Divide the rate, multiply the time. So here now, I can say now that the time is, how much is the amount? Let's go to the example again. Find the future value, accumulated or maturity value. It means in the future. For a saving certificate with a principal of 5,000. So here we have now the P. Let me go and take your slide. The P is the principal will equal 5,000. The principal is 5,000. The R, or the rate of interest, is equals 1%. This after the conversion, after we convert it. And the time equals 20 quarters. So change everything into quarters now. So I want to say FV or future value will equal P multiplied by 1 plus R, that is power N, or power time. So when we substitute in the formula, the future value will equals Here the P is 5,000. Control and C. It's 5,000 multiplied by 1 plus the R. The R is 1%. 0.01. This is multiplied by plus. This is plus, sorry about that. 1.1. That is power 20. So we'll get now 101 power 20. We'll go to our calculator and see here. We'll get 101, 1.01. That is XY 20. That will equals, that's amount 1220 and so on. So we'll take here like around, that's more than enough. It's more than enough to take it, that's fine. Control and C, and go back to our example here and write the future value by this way. And then this is multiplied by 1,000 by 5,000 times the outputs which we got right now. So again, we'll go there and say multiplied by 5,000 multiplied by 5,000. That will equal, this is 6,195 cents. Control and C. And we will go right now here and say, here it is, will equal Control and V, 6,195 cents. And here is the result which we got from this example. I showed you right now what to do regarding if the rate is quarterly and if the time is quarterly as well. We have to change all them to a point of a year. So if it is quarterly, that means I will work the whole year is 4%. So each quarter is 1%. The whole year is 4%. But for each quarter, it's only 1%. This is the first point. And for the time, the quarters will equal the number of years, and each year is 4 quarters. So they will have 20 quarters. Then I will divide. What I did? I divide the rate and I multiply the time. But if I give you annually, not quarterly, then in that case, take the annual and work on it. That's it. Okay. But also, in that case, the years would be 5. So the power would be 5 if it was annually, like what we did before.